All right, I want to do one more example with you, and it's a little bit different. This time it's asking you to find the force of friction. So it would be something like a 1,500 kilogram car rounds a banked curve, perfectly banked for 15 meters per second, so we can find the angle from that. It's going around at a speed of 25 meters per second. If the radius of the curve is 90 meters, what must the force of friction be? The force, not the coefficient this time. So if we look at the question we had just done on the practice problems, we found the coefficient of friction. Of course, if you have the coefficient of friction, then you can always go back and you could sub it in here and you could get the normal force, right? Because it's dependent on the coefficient, and then you could find friction, FFR equals mu Fn. Okay, so that's one way to do it, but it's not the easiest way. So I want to show you a cool, easier way. I could first say, and maybe you might want to, like stop the video and try this, probably this way, to see what you get. Okay, so feel free to do that if you want. And whether you did or not, here's the first step, which is finding the angle. So here's my car coming out of the page. This is my FG going down, my Fn going up that has its two components, Fnx and Fny. So the first step then is to get this theta. So we do sum of the forces in the y direction equals MAY, which goes to 0. So Fny, whoops, lost the n, minus Fg equals 0. So Fn cos theta equals mg. So Fn equals mg over cos theta. And then you go to the x direction. Sum of the forces in the x direction equals mv squared over r. So Fnx equals mv squared over r. So Fn sine theta equals mv squared over r, where the Fn is, fill it in here. So mg sine theta over cos theta equals mv squared over r. The m's cancel, take sine over cos becomes tan, take the g down. The V was 15 meters per second. You have to square that, so 225 divided by 9.81 and divided by 90 meters. Do inverse tan, and you should get an angle of 14.297 degrees. Okay, so that part doesn't change at all. So now we want to go around at 90 kilometers per hour. And so now we need to put our friction in. It'll have a component in the x direction and a component in the y direction. Don't have enough room to put all this. Oh, maybe I could put it up here. Okay, so again, we always start with the y. And in the y, there's an Fny going up. The Fg still going down, and now the friction going down. And so Fny is Fn cos theta, Fg is mg, and FFRY is FFR sine theta. Now, this time, don't change FFR to mu Fn. When you're looking for mu, you have to change it. But this time we're not looking for mu. We're looking for just friction. So don't break it down into mu Fn. Instead, leave it as FFR and then rearrange for just Fn. So take both the mg and the FFR sine theta over, and then divide by the cos theta. So this will only work if you're looking for friction. It will not work if you're looking for mu. If you're looking for mu, you have to break the FFR down like we have in all the other questions. Okay, but since we're looking for friction, we'll leave it in there. And now we'll go to sum of the forces in the x. mv squared over r. So in the x, we have Fnx plus friction in the x is equal to mv squared over r. Fnx is really Fn sine theta And friction in the x is really friction times cos theta is equal to mv squared over r. So again, do not break your friction down into mu Fn. And whoops, there's an Fn here. So now where there's only one Fn, sub this in. So it becomes mg plus friction sine theta over cos theta, and then times sine theta, right? That's that sine theta, plus FFR cos theta equals mv squared over r. All right. So we're trying to solve for friction, and there's one stuck in the bracket, so we need to get rid of this bracket. So probably the first thing I would do would be multiply everything by cos theta to get this cos off the bottom. So it would be mg plus friction sine theta, and when I bracket outside sine theta, plus, and when I multiply this by cos theta, it will be FFR cos squared theta is equal to mv squared over r, and don't forget to multiply it by cos theta as well. Okay, so now multiply through the bracket. So mg sine theta plus FFR sine theta times sine theta is sine squared theta. FFR cos squared theta equals mv squared over r times cos theta. Trying to solve for friction, so you want to keep these two terms with friction on one side and take this guy to the other. So FFR sine squared theta, FFR cos squared theta equals mv squared over r cos theta minus mg sine theta. And I'm thinking that some of you probably recognize what comes next. Pull out the FFR, and when you do, you get my favorite, most trig identity in the whole wide world that you all should recognize, because I do believe it's first semester grade 12 math. I don't think it's second semester. Right? Sine squared theta, cos squared theta. This is just 1. And so this whole side just becomes FFR. And this side, now you know all the numbers, fill them in. So 1,500 kilograms. The speed was 25 meters per second squared. The radius was 90 meters. Cos of 14.297 minus 1,500 kilograms, 9.81 meters per second squared, sine of 14.297. Now, isn't that cool? So last semester when you were learning these identities and you're like, when am I ever going to use them? In physics, to make your life easier is when you're going to use them. Assuming you can punch this in your calculator correctly, you should get 6,460.1896 newtons. Now, you might say, but how come we can't always do it like this, even when we're looking for mu? And the answer is because usually when you're looking for mu, I don't give you an m. And so you wouldn't be able to find your value for FFR. Because if you could, then you could fill it back in here and you could get your Fn, and then you could find your mu. But usually when you're looking for mu, I don't give you a value for m, and so I force you to do it the other way. But if you're looking for FFR, I have to give you a value for m, and you can do it this way and use the coolest trig identity in the whole wide world. All right, so tonight you'll get to practice it.